We're going to learn how to graph sine and cosine graphs or functions. And first we're going to talk about how they look and the different parts, the general form, and what each part of that general form can do. So let's look at sine first. You can see sine, the parent function, as y equals sine of theta or y equals sine of x. They use theta and x kind of interchangeably, so both of those are acceptable. So we're going to start with our general form for sine. So we have y equals, and if we have a number in front of sine, we're going to call it the a, and the a is the amplitude. So we've learned already a little bit about amplitude, that we know that basically is just the radius, and it's that distance from the midline to the highest or lowest value, and it's always positive. Okay, so then let's look at our next piece. So we have sine and then a parentheses, and we have a space and a theta. And whatever number goes here, this is our b, is our period. And we've learned about that as well. So we know it's the time it takes to complete one cycle or one revolution. So our next piece that we possibly could have is something inside the parentheses subtracted. So we're going to subtract the c, and that is a phase shift. And we'll talk more in detail about that later. So phase shift is what moves the function left or right. And notice that the negative is part of the general form. Then we can also have something stuck to the end, and that would be a plus a d. So this is our general form, and our d is our vertical shift. All right, and that's the up and down. So whatever we see there, we know if it's positive, it's going up, it's negative, it's going down. When we look at the C, we have to think about the difference of what's going on there. Start at the midline. Okay, all right, let's look at our cosine. Our cosine's general form is very similar, looks exactly the same. We're going to have an A here, but our cosine instead of sine. And our A, again, is our amplitude. Then we have our B, which is our period. And then we have our C, and it's always minus C. And this, again, is our phase shift. So let's just do a little copy here. Oh, got a little bit of that there. All right, and then we have possibly something attached to the end, and that would be our plus D. That is our vertical shift. Now these start at the minimum or the maximum, depending on if our A is positive or negative, meaning we know amplitude's always positive, but there could be a sign in front of that piece there that causes it to go different directions, and we'll see that in our examples. Let's review some of our basic vocabulary. So amplitude is the distance from the midline to the lowest or highest value, and it's always positive. Another way we can think about this is our radius. Okay, and then we have a period. A period is the time it takes to complete one cycle or one revolution, and the way that we find that is we take whatever our full revolution is in radians, which we know is 2 pi. That's a full unit circle, and if we stretch that on a line, it's also 2 pi, and we divide it by our b, the number of periods that we have, which we find in our general form. A scale or scalar is what we use to count by on the x-axis. So, like, what do I put as my, different values of each grid line? Especially when we're doing radians, it can be a little overwhelming looking. So what we do is we take the period, whatever our period is, and we divide by 4. because we know in a circle, we can evenly split it into 4. So we think about, we start at 0, then we go to 90, 180, 270, and back to 0, which is 360. So we divide it by 4. Now a vertical shift moves the midline up and down. And if there is no vertical shift, then the midline is the x-axis. Our first example, y equals sine of theta. We're going to look to see, do we have anything? So in front of our sine, we do not have a number, so we know that that is a 1. So our amplitude is a 1. Now we look to see if we have a b. So a b would be something that would be right after the sine and right before our theta. And in this case, we don't have anything there, so we know it is also a 1. So b is a 1. So our period is 1 full period. For our c, we have 0. For our d, we also have 0. For our period to be in radians, we have to think about our 2 pi divided by b. The way to find our period, we do 2 pi divided by b. Well, our period is 1, so 2 pi divided by 1 is still 2 pi. We use the number of periods to find our scale, and in this case, we've already found our period, which is 2 pi, so we do 2 pi divided by 4. And that would simplify down to 1/2 pi, or just pi over 2. So our scale is pi over 2. So the way that works is we know that 1 full period is 2 pi. So if we think about our graph as 8 individual pieces, so 1, 2, 3, 4, 5, 6, 7, 8, because we got to go 2 full periods. That's why I made 8 instead of just 4. If we want to think about just our first 4, that's our first phase. So we go just the section. We know that our period, 1 period is 2 pi. So we know this has to be a 2 pi. And then we can think about finding what we're counting by. Well, we know that we're counting by a scale of pi over 2. So we know our first is going to be pi over 2. So then to fill in our rest of our spots, we are then just adding pi over 2 each time and see what we get. So if I did that math, I have pi over 2 plus a pi over 2, I'm getting 2 pi over 2, which actually simplifies down to pi. So I know this piece would be pi. And then if I add another, and I'm not simplifying this, but I'm going to add another pi over 2, and I end up with 3 pi over 2. So there's 3 pi over 2. And then I'll continue that again. So if I did another pi over 2, I end up with 4 pi over 2, which simplifies down to 2 pi, and I already have that there. Then I add another pi over 2, because that's my scale, and I end up with 5 pi over 2. So this is the 5 pi over 2. I add another one, pi over 2, and I end up with 6 pi over 2, which simplifies down to just 3 pi. And then again, pi over 2, and I get 7 pi over 2. And then a last one, pi over 2, and I get 8 pi over 2, which equals 4 pi. So those are going to be my 2 full periods. So I knew my period was 2 pi, so that's how I knew it. I knew my scale was pi over 2, and that's what I'm adding each time. Remember that Desmos can also help you with this, so utilize that resource as well. When we did the Ferris wheel, it went up, down, and back, and it never went across the x-axis. But sine functions, as you've seen in Desmos, actually start at the midline. So in this case, our midline, if we do not have a vertical shift, which we do not, then our midline is our x-axis. So that helps us know where to get started. So if this is our midline here, We have an amplitude of 1, which means we know that 1 above the midline is going to be the highest it goes, and then 1 below the midline is going to be the lowest it goes. Okay, so it's got to touch each piece as we go. So we think we start here, it's going to go up because this is positive. There's nothing in front of this that tells us it's a negative sign. So if I'm looking here, I don't see a negative at all. So I know I'm going up. So I'm going to go here, up, and these are going to be kind of curved. So I'm going to do my dots first. Then I'm going to go down, touch my next because I'm counting by pi over 2. Then I go down again, and then back up, and continue up, and down to the bottom, and back up. So when I connect it, it ends up looking like a true wave. And that is 2 full periods. It's here, and we can see it started at the midline, it went up, come back to the midline, went down, and come back to the midline. So we had a starting and stopping point at the midlines. So that is 1 of our periods, okay? 1 complete cycle. And then we had the same thing happen, and it repeats exactly the same over and over. Cosine, and we're going to look at and see what we can find. So we're looking for our amplitude, our period, our scale. We're looking for phase shifts and vertical shifts to see if we have any. So take a second and see if you can find those. We look first at our form here. We didn't have any number in front of the cosine, so we know that's a 1. There's no negative, so it's a positive value. So we have an amplitude of 1. We have no number in front of our theta, so that tells us there's a 1 there as well. So that means that our period is also 1, and we'll use that to find the total cycles it'll take, and then use that to find our scale. We do not have a vertical shift, and we do not have a phase shift. So that's simple and easy, not to have to deal with that. So now let's look about finding our period. Well, we have 1 period, and remember to find period, we take 2 pi, because that's a full revolution on a circle in radians is 2 pi, and we divide it by our number of periods, which in this case is 1, so we know that 1 full period is 2 pi. So that means 1 full cycle will start at wherever and end at 2 pi. And now let's use that to find our scale. So our scale, we take what we have for our period, this here, so 2 pi, and we divide it by 4. Well, that simplifies down to a half pi, or pi over 2. So that means that's what we're going to count by. So same as last time, we would start for 1 cycle, pi over 2, add pi over 2 again to that, and we would end up with pi. Add another pi over 2, and we'd end up with 3 pi over 2. Add another pi over 2 to that, and we end up with 2 pi. Now, this is 1 phase. This would be 1 phase right here. And then I continued it on, and we went all the way to 2 phases, because we were instructed to graph for 2 phases. We have a vertical shift. We know that our midline is our x-axis. So let's mark our midline here. Our amplitude is 1. We know that from our midline and add our amplitude, we get to our top. So our amplitude makes us have our top at 1 and our bottom at -1. Now, this is a cosine. So cosines are going to start at either the minimum or the maximum. But if there's a negative sign or a positive sign, that's what tells us. So if there's a positive sign, we know it's going to start at the max. And if it's a negative sign, it's going to start at the minimum. So this is a positive sign. So our graph is going to start at our max. And then it's going to flow down just like a wave. So we're going to go to our next spot because we're doing by pi over 2. Then our next, it hits the minimum. then back to the midline, then back to the top, and then back to the midline, back to the bottom, midline, top. And when we connect them, we end up with a graph as such. So when you look at the difference between a sine and a cosine, you can clearly see what's happening. These are both positives. We have one start at the midline, the other one start at the max. So they do look a little different. Sometimes you have to really focus on what is what. So I want you to try to find what you need for 3 and 4, and then come back and check. So for 3 and 4, I found my amplitude, my period, and my scale for each of those. I do want you to notice that there is a negative sign in front of this cosine one. And when it's negative, that means that we're going to actually start at the minimum. So we'll talk about that when we graph. Now, when we find our scale, sometimes it looks a little weird. We had pi over 2, and then we have to take that and divide it by 4. That's the same thing as saying pi over 2 times 1/4, and then I simplified. And the same thing happened over here. And we had differences because we had a period that was 4 here instead of 1, and 3 here instead of 1, like on the previous ones. So now we're going to go ahead and graph. Now, before we do, let's talk a little bit more about how you would find that scale. So we are counting, our scale is going up by pi over 8. Now your graphs have them on there, but very small. So this would be pi over 8. And then we would add pi over 8 again, repeatedly for each piece. So if I add another pi over 8, I'm getting 2 pi over 8, which we know would then simplify down to 1/4, or pi over 4th. Then I add another, and I get 3 pi over 8. And then another, and so on. So when we see that scale, we have it here. So you can see I have pi over 2, 5 pi over 8, 3 pi over 4, 7 pi over 8, and then pi. Now, our 1 period, 1 full revolution, or 1 full cycle, is going to actually stop midway. We're doing 2 phases, or 2 cycles. So we know that 1 full period, based on what we know up here, is pi over 2. So here, in this section, we've got 1, 2, 3, 4 spots, just like 4/4 of a circle. That is going to be our 1 phase there, 1 cycle. So we're going to do that for 2 times. Now with this one, we're sine, and when we do not have a shift, we know that our midline is at the x-axis. So we're going to go ahead and highlight that to help us. Our amplitude is 2, which means from our midline we have to go up 2, because amplitude added to our midline is where our max would be. And then also subtracted, that's where our minimum would be. Now, because this is a sine, we know that we start at the midline. So we're going to start at our midline. And then it is positive. There's nothing here that tells us to do negatively. So this is positive, so we're going to go up. And we are going to go to the next place, to our top. Then back to the next, to our midline. Then to our bottom. Midline. Top. Midline. Bottom. And midline. Notice we started our midline, we ended our midline. So when we connect, we have a cool wave graph. Let's see how you did with number 4. So we had a negative sign out front here. Our amplitude was 1 because we did not have any kind of shifts over with our C and D. Or actually our D, we had our midline at our x-axis. And then I went ahead with my amplitude, that's 1 away, so 1 and -1 is where the top and bottom would be. And because we had a negative, we actually started at the minimum. So we start and we touch every piece. And notice that we went through 2 phases. So when we start here, we would go up. Our phase would end right here the first time. So we go up and then back down. So we started middle, top, middle, down. Bottom, middle, top, middle, down. So we've completed 2 full phases. I want you to try the rest of the notes on your own, and then you can come back and check to see how you did. I will have them completely done for you, and then you can see how well you understand the material. All right, if we look at 5 and 6, we can see our different pieces. Now, I added a little extra to help you. So when we're looking, these are both sines. So we have no vertical shift, and that vertical shift is what tells us if we start where the midline is going to be. When there's no vertical shift, we know it starts at the x-axis. Neither one of these have vertical shift. They both start at the midline. So then we look to see what kind of sign do we have in front of the function. So on number 5, we have no negative sign, so we know it's positive. So it's going to start from the midline and go up. That's how it's going to start. Number 6, we have a negative sign in front. So it's going to still start at the midline because there's no vertical shift, and we are actually going to go down in our starting. Okay, so when we look here, we notice that when we got a scale of a number. So then we count by regular numbers. So that can happen even when we're doing trig functions. For number 7, we don't have a vertical shift, which means that our midline is at the x-axis. So in this case, we have a cosine, and cosines start at either the minimum or the maximum, depending on what's in front. If we look right in front here, we have a negative. That means it's going to start at the minimum. We found our scale, and I went ahead and put our scale, so check and make sure your scale is correct. It was not given to you originally. And then we graphed. So our cosine started at the minimum value. The reason we're at -1 is because our amplitude was 1. So 1 away from the center, 1 up from the center is our amplitude. So that's our minimum and our max. For number 8, we did have a vertical shift. Our vertical shift out here was our -3. So our D was a -3. So when that happens, we have a vertical shift, we actually move our midline down 3. So without 1, we're at the x-axis. So if we have to go down 3, our midline is now at -3. Now, that doesn't change where our amplitude's going to go. It doesn't stay. It travels with the midline. So again, it's 1. So it's 1 away from where our midline now is at -3. So we have -2 and -4. And this is a sine function. So a sine function always starts at the midline of our graph, not necessarily the x-axis, because we knew our midline moved here. So we start here, and it's positive. There's no negative sign out front. That means it's positive. It's going to start going up, and we have done 2 phases. Now go check on 9 and 10 and see how you did on those. So if we look at 9 and 10, we had a cosine, found our amplitude, we had a period of 1, we did have a vertical stretch of 1 as well, and that moves our midline up 1. So we found our period, 2 pi divided by our b, so it got us 2 pi, and then our scale, we take our period and divide by 4, and we end up with pi 2. So we're counting by pi 2. I did have the scale on here. This is a cosine, so we start either the min or the max, and because this was positive, we're going to start at the max. So then I did my graph. Now, do know that some of these graphs have been stretched or whatever when they were put in, so they may look a little wonky compared to what you would have if you put this into Desmos to see it. Now, for 10, we had an amplitude of 3. We had a period of, our B was 3, and sometimes that's called frequency. They see how often it happens, so sometimes they call this frequency. Okay, we're using it to help us find our period. That's why it's called period as in general form. So then we found our period, 2 pi divided by 3. Can't simplify any further. And then use that divided by 4 to find our scale, which ended up being pi 6. Now, when we look at pi 6, we start with a pi 6 and add pi 6 to it, or 1/6 pi to it, and we get pi 3 and so forth to end up with 2 phases. With this one, we had a vertical shift of 2, which means that our midline moved up 2. Normally, it's at the x-axis, so now it moved up to 2. And then that made our amplitude, if we start at 2, we add 3 to that, we're at 5, and we're at -1. So then we did our graphs. Because this is a sine function, we start at the midline, and because there was a negative sign out front, we had to start going down first. Now you'll move on to your homework and get a lot more practice.